Difference between software engineering and software programming. I was reading a book, Software Engineering at Google. The first chapter was interesting. In first chapter, it discusses what is the difference between programming and software engineering. According to first chapter, software engineering is software programming with three additional dimensions. What are those dimensions? These three additional dimensions are time, scale, and trade-offs. Let's discuss each dimension in details. What it means that software engineering is software programming plus time, scale, and trade-offs. So let's take first dimension, time. As time passes, software deteriorates. It becomes very difficult to maintain, add functions. It becomes very rigid, easy, very brittle. If you fix one bug and 10 bugs are introduced, if it is not designed properly. So that's where all the software engineering good practices comes into the picture to make sure that software is maintainable over the time period. So you use continuous integration to make sure your software is in good quality, in your source safe, is passing tests, is passing acceptance criteria. You use refactoring to make sure you take care of the software decay over the time, remove the smells, remove the bad code, and all the solid principles, all the design patterns comes into picture to make sure our software is maintainable over the time. Over the time, operating system changes. We had Windows 7, 10, and before we have 95 different versions. Hardware improves a lot. The computing paradigm changes over the time. First, we had client-server computing, then we have web-based computing, then now we have cloud-based. So you have to design your software to take benefits of these shifts in hardware, computing paradigm, or make sure your software is upgraded to new operating system. For example, let's take microservices. One of the definition of architecture used to be that architecture and design, these are the decisions which are hard to change. The microservices architecture changed that. It made changes easy because you are deploying application in smaller chunks. Now let's come to scalability. We can imagine now the platforms are available to everyone in the world. The platforms like Google Search, Facebook, Twitter, WhatsApp group, they are managing billion of users. So they have, when you're designing those kind of applications, you have to think of scalability where so many millions people are hitting your platform. How many billions of transactions are being generated. Again, your software should be well architected to scale over. Suppose you are moving from web server architecture to cloud computing architecture. So if you are just taking your applications moving from web server to cloud computing, you're not really taking advantage of cloud computing scalability. You take advantage of cloud computing scalability when you use microservices architecture. That way you are able to scale independent component. You may have a catalog page. Traffic on catalog page is going to be a lot higher than on the orders. So you have to make sure that your catalog page is deployed on multiple servers. Now we discuss time dimension, scalability dimension, and let's come to the third dimension, trade-off. In software, we make trade-offs. For example, if we are concerned about performance, but we are also concerned about scalability. What is scalability? Scalability is, can your application scale if number of users of your application increases exponentially. Suppose 1000 people were using your application. Now 100,000 users are using your application. Can your application handle that kind of load without significant degradation in the performance? So to make our application scalability, we use multi-tier architecture. We deploy our business layer in different application servers, data access layer in database servers. So as we are using distributed architecture, the performance will decrease. They're gonna be inter-process, inter-machine communication, which may decrease little bit performance, but it will increase your scalability of application. It will make sure you don't have a one-point failures. If one server fails, other servers take over. Now let's talk about security. For security, you are going to deploy your application on multiple servers, which will decrease, that way may impact performance. So you have to make a lot of trade-offs. So friends, today we discuss what is the difference between software engineering and software programming. Software engineering is software programming with 3 additional dimensions. These dimensions are time, scalability, and trade-offs. So friends, if you like this video, like it, share it, and subscribe to my channel for your regular updates. Also connect with me on LinkedIn and Twitter, especially LinkedIn. If you like small summaries of the video, I will be posting a lot of small summaries of the video on LinkedIn. Thanks again.